All right, this continues our lecture on section 6.6. We're seeing if ordered pairs are solutions to a linear inequality. So this is done just like a linear inequality, or like a linear equality in two variables, except for now we have the inequality symbol to deal with. So this one says 5 times y, which is a -1, plus 2. We're questioning whether that is greater than a -7 times a 0. And so what we have here is a -5 plus 2, which is a -3, and we want to know, is that greater than 0? So that is a false statement, and this is where you may have the difficulty, is being able to read those inequalities. So we say -3 is greater than 0 is false, and therefore this is not a solution. So that's how we tell, just like we did with a linear equation. Now, when we had linear equations in two variables, when we found if it was a solution or not, what we were looking at was just being on a line. Well, these are no longer just lines. What we're going to be using this for is to tell us where that great big region of solutions are. So let's do it again. We have 5 and y, which is a -1, and then plus 2, and we want to know, is that greater than a -7 times a -1? And so now we have -3 on the left, because that's the same, and we want to know, is that greater than -7 times -1 gives us a +7, and again we're seeing a false statement here. And so again we're going to see that we have not a solution. Now let's go on to the third one, and again we're going to plug it in, 5 times, and this time we have 1 and then plus 2, and we're asking, is that greater than a -7 times a -1? And this time around we are going to have 5 plus 2, which is 7, is greater than negative times a negative, which is a positive, which is a +7. Now that isn't quite a solution. It's still a false statement, because 7's not greater than 7, it's equal to 7. And what we have here is actually a special case where what we see is a ordered pair that's actually on what we call the boundary line. And in this particular inequality, the boundary line is not part of the solution, because it's like with the linear inequality in one variable, where we had it just simply being the place where it started, and we had, in the old way of notating, it being an open circle, and in this it's kind of going to be the same idea, right? Nothing on the boundary line would actually solve this. So we'll see that as soon as we come down here to solving a linear inequality in two variables. So solving a linear inequality in two variables is actually a visual process. We're going to be graphing a boundary line. That's the y equals mx plus b form, and then if it is an equality, a strict equality in the inequality, we will make a solid line, and if it's a strict inequality, a less than or greater than, then we're going to make it a dotted line, because those boundary lines aren't included, points that are included in the solution, just like we saw with that last problem. And then we're going to choose 2 checkpoints, and we're going to do just like what we were doing in the last example, checking to see if they're solutions, and then we're going to shade the appropriate region. So our next step is to actually solve this problem right here. Y is greater than or equal to 2x plus 4, and then to shade in the region that's appropriate by using the checkpoint method. So I'm going to let you go ahead and try to graph that boundary line on your own. In the next video, I'll graph the boundary line, and then we'll do the checkpoints. So I'll see you in the next video.